everyone. So today we are going to talk about the force of friction. Now, friction always acts on materials that are in contact with one another, and it always acts in a direction to oppose the motion or intended motion. So even if something is not actually moving, there might still be friction opposing that intended motion. Think about if you're trying to push something, but it's not actually moving yet. The reason that object is not moving yet is because there's friction involved. So friction is due to irregularities on the surface of two objects, between two objects, when they're in contact with one another. So it's like a microscopic view here. And when one object slides against the other, it must either rise over those irregular surfaces or bump, like scrape them off. And either way requires a force. So the equation for friction looks something like this, and we'll kind of dive deeper into this equation in the next video. But it's the basic equation is just the friction force is equal to mu times normal force. That little like fancy U symbol is called mu, mu. So again, this is the friction force. This is what is called our coefficient of friction. Mu is the coefficient of friction. And then F sub n, of course, we know is the normal force. So what this equation tells us is that the magnitude of friction depends on the type of material in contact and how much those surfaces are pressed together. So the higher the mu, or the coefficient of friction, the higher the friction force, and that has to do with the type of material that's in contact with one another. This is like a constant for different materials, and you can actually look this up online. So something, for example, like rubber and concrete produce more friction than steel on steel, and you can see this example on the right-hand side right here. This is why we're moving toward more of those concrete barriers on the freeway, because since it has a higher mu between rubber and concrete, that will slow a car down that's out of control faster than like the steel or the metal of the car on the metal of those old guardrails like that. So because of the higher coefficient of friction, that car gets slowed down faster and maybe less damage to the car as well. Now, also, we know that heavier objects produce more friction. Remember that equation was force of friction equals mu times normal force. The heavier the object, the more the normal force, right? So heavier objects are going to have a greater force of friction. And that makes sense because that heavy object is really pressed into the earth more, or whatever the ground, whatever surface we're on. So because, like I said, the normal forces are bigger. Now, a special case here is if an object is going at constant velocity. Now, when friction is present, an object may move with a constant velocity even if we have an outside force applied to it. Now, in this case, because we know that at constant velocity we have no acceleration, the forces are balanced. So the force of friction will equal the applied force because the net force is 0. So like I said, no acceleration means constant velocity. So this is a special case because if they tell you in a physics problem that the object is moving at constant velocity, this should tell you right away that the friction force equals the applied force. Of course, this is if we're on level ground. So that's a really special case, and you want to remember that for when you're solving these problems.